Hi YouTube, Timothy Unkert here. In this video, I want to talk about simplifying square roots. So a lot of times in mathematics, you'll have to break down a square root and teachers will want you to simplify it as much as possible. So I think what's best is we go through a couple examples and I'll explain my process. The idea here is that you want to break down your square root into factors, some of those factors that you can, some of those factors being a perfect square. So for instance, let's look at the square root of 343. If you have good number sense, you'll know this is divisible by 7, but a lot of times you won't know that. So you have to start breaking it down, thinking about it. And the first thing you want to look, is it divisible by 2? Well, it ends in a 3, so it ends in an odd number, so that's not the case. Is 343 divisible by 3? Well, you can check that by going 343 by taking the digits and adding them together. So 3 plus 4 plus 3. Well, that's going to be 7 plus 3, so that's 10. Now, you look at the sum. Is the sum divisible by 3? In this case, no. So it's not divisible by 3. Okay. So then we move up. Is it divisible by 4? Well, again, if it's not divisible by 2, it's not divisible by 4. Move up again. Is it divisible by 5? Well, this ends in a 3, so it would have to end in a 5 or a 0 to be divisible by 5. Is it divisible by 6? No, because it's not divisible by 2. Okay, so then you want to check, is it divisible by 7? So let's just go ahead and divide it. So we'll do 343, and if I go 7 goes into 34 4 times, and 4 times 7 is 28. So we subtract that, we get 6, bring down the 3. Well, 7 times 9 is 63. So this is divisible by 7. Okay, so that gives me a clue. Okay, now I can start breaking it down. So it's going to be basically 49 times 7. So I can rewrite this as square root of 49 times, and I'm using the uh, middle dot here to represent multiplication, 49 times 7. We can now break these into separate square roots as square root of 49 times the square root of 7. Okay. Well, 49 is a perfect square. 49 is 7 times 7. So the square root of 49 is 7. So I can rewrite this as 7 times the square root of 7. And I don't even need the mid dot here. If I just write 7 next to the square root of 7, that means they're multiplied together. So 7 square roots of 7. Now I look, can I break this down any bit further? And, well, square root of 7 is an irrational number, and the only factors are 1 and 7. So I really can't break it down any further. So I've simplified this as far as I can go. So this would be the simplified version of the square root of 343. Okay, let's take a look at another example. Okay, in this second example, we're going to simplify the square root of 3,125. Now, I'm getting a big clue here. This ends in 5, so I know it's divisible by 5. So I'm going to start dividing by 5. Okay, so if I take 3125 and I divide it by 5, well, 5 goes into 31 6 times. And 31 minus 30 is 1. Bring down the 2. Bring down the 5. So we got 125. Well, 5 goes in 12 twice. 12 minus 10 is 2. Bring down the 5. And 5 goes into 25 5 times. And we have no remainder, so we know, yep, this is divisible by 3125 is divisible by 5. I'm going to write this as 5 times 625. Okay, so let's keep going. Let's pretend we didn't know 625, the square root of 625 was 25. So how would we figure this out? I'm going to make room here by just getting rid of all this stuff. So, well, 625 is divisible by 5. So we'll do 625 divided by 5. So 5 goes into 6 once. 6 minus 5 is 1. Bring down the 2. Bring down the 5. 5 goes into 12 twice. 12 minus 10 is 2. Bring down the 5. And 5 goes into 25 5 times. So, and again, there's no remainder here. Okay, so we can break this down further into now 5 times 5 times 125. Okay, and well, 5 times 5 is 25. Square root of 25 is 5. So, another way I could write this is square root of 25 times 125. So we're simplifying it already. So now we've got, 5 times 125 because the square root of 25 here is 5. Okay, but we can continue to break this down. So let's make some more room. Okay, and now let's divide 125 by 5. So 5 goes into 12 twice. 12 minus 10 is 2. Bring down the 5. So 5 goes into 25, 25 times. So, well, 5 goes into 25 5 times, really. But 5 times 25 is 125. Okay. All right. So we can break this down into 5 times the square root of, let's do 25 times 5, which can be further broken down into 5 times the square root of 25 times the square root of 5. Well, the square root of 25 is 5, so we have 5 times 5 times the square root of 5. 5 times 5 is 25. And then we have times the square root of 5. Now, the square root of 5, that's an irrational number. Only factors are 1 and 5. You really can't do anything with that. So we've simplified square root of 3125 to 25 square roots of 5, and that's as far as we can go with this example. Now let's take a look at a couple examples where you have an imaginary number arise. Okay, in this third example, we're simplifying the square root of negative 625. Okay, so we know that the square root of 625 is 25 from the previous example. So let's break this apart. So we're going to break it apart into negative 1 times the square root of 625. Okay, so Well, we want to look at what is the square root of -1. Well, in mathematics, the square root of -1 is I, which represents an imaginary number. And the reason we have this is, well, you can multiply a negative times a negative and get a positive, and you can multiply a positive times a positive and also get a positive. But you can't multiply any number by itself and get a negative number. So it's imaginary. But the weird thing is, it's actually used in real world situations such as electrical engineering and so on. And you also have complex solutions arise using the quadratic formula, um, which have imaginary components. So it does happen. And what we're going to do, we're going to break this apart. So we have the square root of -1 here times the square root of 625. And we can break those apart to I times the square root of 625 is 25. Now the convention is when we write this at the end, in our simplified form, we'll write the number first, and then we'll write I next to it. That means 25 times I if we write them next to each other. And so we write the imaginary part, or the imaginary, yeah, we write I second. Okay, so we write it like this. So this square root of -625 simplifies to 25I. And we're done with that example. Okay, in the last example I'm going to cover in this video, we're going to simplify the square root of -828. Now this one's not going to be as nice and neat. It's going to be a little bit messy, so let's dig into it. So first off, I notice there's a negative number here. So I'm going to break this into -1 times 828. Okay, so if I do that, well, I can get the square root of -1, which we know is I, times the square root of 828. Okay, and the square root of -1, again, we'll write as I times the square root of 828. Now, interesting thing here is that I notice that 828 ends in 28. That means if the last two digits are divisible by 4, then the number is divisible by 4. So let's divide 828 by 4 to see how we can break this apart. So 4 goes into 8 twice. And that would be 2 times 4. Let me fix that. 2 times 4 is 8. 8 minus 8 is 0. Bring down the 2. Bring down the 8. 4 doesn't go into 2, so we'll say 0 here. But 4 goes into 28 7 times. Okay, so we can break this into I times the square root of 4 times the square root of 207. Okay, so square root of 4 is 2, so I can write this as 2I square roots of 207. Now we look at, this ends in a 7, so it's not divisible by an even number, but let me make some room here. But if I add 2 plus 0 plus 7, well, I get 9. And I know 9 is divisible by 3. So I'm going to divide 207 by 3. So 3 goes into 26 times. 6 times 3 is 18. 20 minus 18 is 2. Bring down the 7. 3 goes into 27 9 times. So, and we have no remainder there. Okay, so we can rewrite this as 2i times the square root of 3 times 69. Okay. All right, so let's make some room because we can break down 69 here. So you know, 6 plus 9 is 15. So 15 is divisible by 3, so 69 is divisible by 3. So 3 goes into 6 2 times. So 6 minus 6 is 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. So 9 minus 9 is 0. So I can break this apart into 2i times 3 times 3 times 23. Okay, so if I look at this, well, I can really write this as 2i. 3 times 3 is 9, so I can write this times the square root of 9 times the square root of 23. The square root of 9 is 3, so I can make this 2i times 3 times the square root of 23. All right, so 2i times 3 is 6i. And we have times the square root of 23. Now 23, the only factors are 1 and 23. It's a prime number, so we can't break that down any further. So we're going to leave our solution as 6i square roots of 23. And that's going to be it for this video. Hopefully it was helpful to you. If it was, please like and subscribe if you haven't done so already. And thanks for watching. I'll leave a link to a worksheet on Teacher Pay Teachers I'm going to put up for simplifying square roots for parents and new math teachers who want that. I'll probably make it like 99 cents. So check that out in the description. Thanks for watching. Hope to see you in the next one.